Antarctica is often seen as a vast, smooth expanse of ice at the bottom of the world, but what lies beneath that frozen surface is a rugged and mysterious landscape that few have ever glimpsed. The truth is, the continent hidden under the ice is full of dramatic features that have remained out of sight until now. But here's where it gets controversial. How much do we really understand about this frozen frontier, and what does it mean for our planet's future? Enter BedMap 3, the most detailed and comprehensive map of Antarctica's hidden terrain ever created. This groundbreaking project has effectively peeled back the icy veil, revealing the rocky continent beneath with unprecedented clarity. It's like having X-ray vision for one of Earth's most remote and least explored places. So what exactly is buried under all that ice? Antarctica's ice sheet holds an astonishing 27 million cubic kilometers of frozen water, making it impossible to see the land directly beneath. To tackle this challenge, scientists developed BedMap 3, a digital map that virtually removes the ice layer to expose the continent's underlying topography. This map is the result of an incredible effort, compiling over 82 million measurements collected over 6 decades. The data is so detailed that it's plotted on a grid with points every 500 meters, offering a high-resolution glimpse into the continent's hidden features. Thanks to BedMap 3, we now know about Antarctica's tallest mountains concealed beneath the ice and its deepest canyons. For instance, the thickest ice, measuring approximately 4,757 meters, rests in an unnamed canyon in Wilkes Land, coordinates 76.052 degrees south, 118.378 degrees east. To put that into perspective, this ice thickness is more than 15 times the height of London's Shard skyscraper. This fact alone highlights the immense scale of Antarctica's frozen landscape. Another eye-opening discovery is that much of Antarctica's ice sits atop bedrock that lies below sea level. This detail is crucial because it means the ice is particularly vulnerable to warming ocean waters, which can accelerate melting from below. On average, the ice sheet is about 1,948 meters thick, and if you exclude the floating ice shelves, the thickness exceeds 2,100 meters. The total volume of ice locked in Antarctica is enough to raise global sea levels by an estimated 58 meters if it were to melt entirely, a scenario that would have catastrophic consequences worldwide. But the revelations don't stop at the land. Scientists also turned their attention to the ocean floor surrounding Antarctica, producing the most detailed map ever of the continent's submarine canyons. These underwater valleys play a vital role in directing ocean currents and determining how heat from the sea reaches the ice above, influencing melting patterns. In total, researchers identified 333 canyon networks, some plunging deeper than 4,000 meters. The eastern coast features sprawling, branching canyon systems with broad U-shaped profiles, while the western coast is marked by shorter, steeper canyons with sharp V-shaped cross-sections. These contrasting shapes tell a story about how glaciers sculpted each side of the continent differently over millennia. Creating BedMap 3 was no small feat. It took decades of persistent effort and a blend of cutting-edge and traditional techniques from around the world. Aircraft equipped with laser and radar instruments flew over the ice to gather data, while ground teams braved harsh conditions, hauling equipment on snowmobiles and sleds. Seismic surveys, which involved controlled explosions, helped map the rock beneath the ice. Remarkably, some of the earliest data even came from expeditions using dog sleds, showing how far technology has come. The final step was harnessing modern computing power to integrate this vast and varied data. Researchers developed specialized software capable of processing millions of bathymetric records and precisely calculating the dimensions of underwater canyons. The outcome is the clearest and most detailed picture yet of Antarctica's hidden foundations. This new map is more than just a scientific achievement. It's a vital tool for understanding how Antarctica might respond to a warming climate. But here's the part most people miss. With so much of the ice resting on bedrock below sea level, the continent's stability is precarious. Could this mean that current models underestimate the speed and scale of future ice loss? And what implications does this have for global sea level rise and coastal communities worldwide? What do you think? Does this new map change how we should view Antarctica's role in climate change? Are we prepared for the potential consequences of a melting ice sheet that could reshape our planet? Share your thoughts and join the conversation below, because when it comes to Antarctica, the story is far from frozen.